Meenta.
Good evening, everyone. My name is Stephen Smith. I am one of the founders of a company called Meenta. I'm the technical side of my dev team. My partner here is the science and the business side. And what I want to talk to you tonight is about science. Specifically, I want to talk about this very interesting behavior that happens in the science world. I'm going to make a fairly hyperbolic statement. Scientists are really bad at sharing. So every year, billions of dollars in the United States are spent by NIH, biotech, pharma, and literally thousands of small startups. And this dollar that's being spent is between $100,000 and sometimes up to $10 million. So very large CapEx expense. And this technology very often is underutilized. We're talking about very large pieces of sequencing equipment. And what we've found is that this technology is often a sticking point for startups. So when a startup goes and gets pushed back from their investors, they say, I want to raise this money and I want to buy certain things. Investors very often push back. And when they push back, they say things like, you sure you need this? Could you solve the science problem a different way? Could you outsource? And this results in a very, very typical knee-jerk response by scientists. Right? No, I need to buy this. I need to control it. I need access. I need speed. And what we've found, in my partner's experience in biotech, is that desire to own your own equipment, maybe it's not the best one. It's a very honest one, but it often has regret, kind of buyer's remorse. Because when you buy a large piece of CapEx, when you convince your investor, hey, I'm going to buy it, you very often lose the ability to pivot. And scientists very often start an experiment one place and find that their experimental design needs change. I thought I needed this, now I no longer need it. But once you bought it and it's sitting on your lab bench, you can no longer pivot out of that cost. You can't get that money back. It's too late. So Meenta is a solution to that. And I'm going to talk to you a little bit tonight about one very specific aspect of science, the topic of genomics. Genomics has very large expenses for their hardware. And that hardware is called next generation sequencers. And these are boxes, maybe the size of this podium, and they can range from $100,000 to $10 million. And these things are spread all over the United States. Move to the next slide. But one of the things we know is that these pieces of equipment that are paid for by us and by investors, they're only used about half the time. That means that half the time, these very large pieces of equipment are sitting completely idle. They cost money to stand still. And we know that if you were to walk into downtown Boston, you get out of the subway stop at Kendall Square, and you imagine all the businesses around you. Just kind of imagine what Kendall Square looks like. There's researchers everywhere. Well, within about a half mile of Kendall Square, there are 300 plus next generation sequencers. Half of them are never used. And we know that even at Harvard alone, they have 10 equipment cores full of not just NGS sequencers, but proteomics and all other scientific devices. So why is this? Why would we spend all this money and not use it half the time? Well, it's a very common and logical problem. Scientists are solving science problems. They're not focused on and not incentivized around being profitable. And when they're pushed back on their investors, they're making a very logical statement. This is risky. I think I can minimize my risk by buying. So we looked at why is outsourcing painful? Well, for the first reason, there's no systematic way to find and access equipment. It's not logical, but you can't get at it. All right? So this equipment is spread all over the United States, and it's in locked gardens. Right? These little locked gardens with a biolab, even though the NIH grant told them they have to share it, it's still locked away. And when a scientist wants to send their equipment out or send their samples out for research work, they often have a long, fairly archaic coding process. This coding process means that they have no ability to measure quality, and their tools for getting at it, like Google, don't help. So when we look deeper at this, what we realize is this results in science taking longer. We waste time, scientists waste time on logistics, which is not the problem they're trying to solve. Scientists buy more equipment, and the total cost for science is higher. So this is Meenta. Meenta is a platform that allows instantaneous pricing, no quotes, no emails, no text messages. You can find equipment anywhere in the United States, and you can instant book it the same way you book a flight to the Caribbean in about 3 weeks when you're tired of the snow. And we give scientists the ability to see quality, understand quality about what they're doing, and more specifically, we give them the ability to respond differently to that investor question. When the investor pushed back and said, you really need to buy it, now we give them the confidence and security to say, well, maybe I would buy half as much. So this is where we started. 2016, we incorporated. By April, we had our first version. By August last summer, we had our first 20 instruments. By November, not very long ago, feels like a long time ago, we had our first 15 users. And we are in the engagement phase right now. We have probably about 10% of the NGS market, of the people in the United States with this equipment accessible on our platform. And we have relationships with the big boys, Broad, people who did the Human Genome Project, Harvard, Hudson Alpha, and WuXi. And we are looking to the future on how we build out this network so that instead of just buying, look, imagine you buy an airline ticket on American Airlines. Well, you could also go buy a package that gives you your shuttle transfer, you can get your hotel, your room and board, your spa visit, and maybe a tour when you hit your vacation spot. The difference in buying is very, very different. So we're looking at building out our future in the next couple of months is how do we build this out so a scientist doesn't buy sequencing equipment, which is not the thing they need to solve. We want to give them the ability to buy a science solution. And that's why we're looking at bioinformatics and sample prep and all these other things that scientists do to solve their problem. And what we're looking for, and the reason we're here presenting, is scientists are spread out through the community. There are husbands and wives, or brothers and sisters, and we're looking for ways to hack this community. To break a status quo around, I have to buy it, I can't borrow it. But we know that the sharing economy has been used in other places, and that's what we're doing. So we're trying to access more researchers, and we're trying to talk to the general public about how do we think about science. I'm out of time, so I'm going to stop and ask questions.
How do you tackle the problem of different instruments having different calibration errors? Like, I rent this instrument now to conduct one experiment. To conduct the same experiment, I get a different instrument now.
Okay,
there
so
will be a variation in my results for the same experiment with the same parameters because the hardware is different.
So his question is how do they control for quality across doing experimental design? So one of the unspoken secrets in this industry is that you can have two of these pieces of equipment and put the exact same sample on them and get slightly different results. I mean, it's both amazing that we have genetics and we're able to reach into the genetic code to learn stuff. It's also amazing that it works at all. So what we do is we try to minimize those failure points. We try to say, the researchers already know how to account for this with bioinformatics. The researcher does not go to the lab. They take their sample, they put it in a box. The box goes to the UPS. We track it. And when it goes onto the machine, we limit the specific outcomes. We basically try to collect metrics on the machine itself over time, and then we try to report that back. So we can't solve all experimental design problems, but we're solving the problem they would have, whether it had to go to a lab in another part of the state, or whether it was a lab in their own place. Hope that answered your question. Sir.
How do you enforce privacy?
Privacy. His question is how do we enforce privacy? Well, the data itself is not tied to a human being. So this is not...
No, I don't mean human privacy. I mean research privacy.
Ah, okay. So we have our own AWS cloud that takes the data and segments it according to the user. So from the time the sample gets sent to the host, and the host runs it and delivers their data back, we move that through our own cloud.
They have the data though. Somebody outside of your
Ah.
startup operating in stealth mode, not able to patent stuff because then it'll get copied in unnamed countries. Now we're learning about your
AWS
work.
has very established security protocols and privacy protocols, well established for the last 10 years in genomics and life sciences. And all those things are written into our terms and conditions and privacy policies, as well as into the attestation that's embedded in the terms and conditions that the host and user sign.
Well, it's a good question, but what we found is as we talk to researchers, So when we first started our year-long problem of talking to people, we started out with a set of assumptions. We assumed people cared about price first. And then they care about speed, and then they care about quality. And we traveled all across the United States and talked to researchers, and we were 100% wrong. And I would say every business needs to talk to their customers before they do anything. They don't care about price at all. They're not spending their own dollars, they're spending research dollars. They care about quality and speed, but the one thing they've never talked to us about is security. Because this data is fairly anonymized. It's large, we're talking about 200 gig files. To steal them would be like stealing used carpet. Like, what are you going to do with it? You can't use it. It's not something you would steal. So I'd love to talk to you afterwards. Maybe there's a concern you have that I'm not aware of.
Thank you. Another attractive point is like they might provide a consistent dashboard. As a startup, I don't want to invest in coming up with my own dashboard. I'll just directly hook into their product and I have everything visible.
This is a big topic. I'm happy to talk to anyone afterwards. But I'm going to give him the book. Thank you very much.